Hi everyone, my name is Michael. So today I'm going to do a lab walkthrough uh, on build your VPC and launch a web server. So here's the lab overview and objective. So here's what we have. In this lab, we will use Amazon Virtual Private Cloud VPC to create your own VPC and add additional components to produce a customized network. You will also create a security group. You will then configure and customize an EC2 instance to run a web server, and you will launch the EC2 instance to run in a subnet in the VPC. Amazon Virtual Private Cloud Amazon VPC enables you to launch Amazon Web Services AWS resources into a virtual network that you define. This virtual network closely resembles a traditional network that you would operate in your own data center, with the benefits of using the scalable infrastructure of AWS. You can create a VPC that spans multiple availability zones. After completing this lab, you should be able to do the following: create a VPC, create subnets, configure a security group, launch a EC2 instance into a VPC. So here is the scenario. In this lab, you build the following infrastructure right here inside the AWS cloud, and inside a regions we have availability zone A and AZ B, and in each AZ we the first one we have the lab VPC. Inside here we also have the lab subnet public one. Inside of this subnet we have the NAT gateway, and there is another lab network private one. In available zone B, they have something similar as well. We have a subnet. Inside the subnet we have the security group web server one, and we also have a subnet private. um, Here is a public route table. Here's a destination and a target. Another one is a public route. Public. I'm sorry. This is private route table. So, similar to above, but we have local and NAT gateway. So, let's start it. So task 1, we're going to create your VPC. In this task, you will use the VPC and more options in the VPC console to create multiple resources, including a VPC, an internet gateway, and a public subnet and a private subnet in a single availability zone, 2 route tables, and a NAT gateway. So in the search box, we go to services and we're going to choose VPC. And then after that, we're going to start creating VPC. So on the top right of the screen, verify that we are in the North Virginia, US East 1 regions. So right here, we are in US East 1 region, North Virginia. And then we're going to choose the VPC dashboard link, which is also towards the top of the console. Then we're going to choose create VPC. Note that if you do not see a button with that name, choose to launch VPC wizard button instead. So we're going to configure the VPC detail in the VPC setting panel on the left. So we're going to choose VPC and more. Under the tag VPC and more, let's see. So under the tag auto generation, keep auto generation selected. However, change the value from the project to the lab. All right. From project to lab, so we need to change this to lab, but keep the auto generate selected. So we're going to keep the IPv4 CIDR block set to this address right here is the default. And then for number of availability zones, we're going to choose 1. Number of availability zones will be 1. For number of public subnets, keep the 1 setting. Okay, number of private subnets, also keep the 1 setting as well right here. Next, expand the customized subnet CIDR block section. Customize subnet CIDR block sections. Then we're going to change the subnet CIDR block in the US East 1 to this address right here. And for the private subnet CIDR block in the US East 1A, we're going to change this to the new address here. Now we're going to set the NAT gateway to 1AZ. So choose a number of availability zones in which to create the NAT gateway. Note that there is a change for each NAT gateway. Okay. And then we're going to set the VPC endpoint to none. There's a VPC endpoint right here, set to none. And then we're going to keep both the DNS hostname and DNS resolution enabled. DNS hostname and resolution enable. So in the preview panel on the right, confirm the setting you have configured on the right. So confirm that the lab VPC is lab VPC. We're going to have a subnets, US East 1A, public subnet, and private subnet. Okay, look good. Route table, looking good. And the net route table right here, it's looking good. So go into the network connection, looking good as well. Okay, so at the bottom of the screen we're going to choose create VPC. Awesome, so it's creating. The wizard has provisioned a VPC with a public subnet and a private subnet in one availability zone with route tables for each subnet. It also creates an internet gateway and a NAT gateway. To view the setting of these resources, browse through the VPC console link that display the resource details. For example, choose subnet to view the subnet details and choose route table to view the route table details. The diagram below summarizes the VPC resources you just created and how they are configured right here. Okay. So we just need to wait for it to finish. So an internet gateways is a VPC resource that allows communication between EC2 instances in your VPC and the internet. The lab subnet public 1 US East LA public subnet has a CIDR of 10.0.0.0-24, which means that it contains all the IP addresses starting with the 0.0.0.x. The fact that route table associated with this public subnet route 0.0.0-0 network traffic to the internet gateway is what makes it a public subnet. A NAT gateway is a VPC resource used to provide internet connectivity to any EC2 instances running in the private subnets in the VPC without those EC2 instances needing to have a direct connection to the internet gateway. The lab subnet private 1US is 1A. Private subnet has a CIDR of 10.0.1.0/24, which means that it contains all IP addresses starting with 10.0.1.x. Okay. So the next task is we are going to create additional subnets. So in this task, you will create 2 additional subnets for the VPC in a second availability zones. Having subnets in multiple availability zones within a VPC is useful for deploying solutions that provide high availability. After creating a VPC, as you have already done, you can still configure it further. For example, by adding more subnets. Each subnet you create resides entirely within one availability zone. So on the left navigation pane, we're going to choose subnet. First, you will create a second public subnet. Let me take a screenshot of this. Okay, now view the VPC first. Taking a second screenshot for this as well. Okay, so this is our created. So we want to choose we want to choose subnet. Okay, we're going to choose create subnet and configure. The below. So for the VPC ID, we are going to choose lab VPC right here. And then for the subnet name, it's going to be lab subnet public 2. Subname lab subnet public 2. For the availability zone, select the second availability zone. Select the second availability zone. US is 1B. So for the IPv4 CIDR block, we're going to choose this. Oh wait, that isn't any other option. IPv4 VPC, nope, IPv4 CDIR block, not that one. Right here. Okay. This one is default. For the subnet, it should be this one right here. And what we want to do is we're going to choose create subnet. Okay. So the second public subnet was created. You will now create a second private subnet. So first of all, we're going to choose create subnet, then configure the following below. Create subnet. We're going to choose lab VPC again. Lab VPC. And then for the VPC ID, we're going to choose lab VPC. We already choose lab VPC. For the subnet name, we are going to choose this lab subnet private 2. For the subnet private name. For the availability zones, we're going to choose the select the second availability zones. For example, US is 1B, so we did choose US is 1B, so we're going to choose US is 1B again, which is the second availability zone right here. For the IPv4 CDI block, it should be this one. And the subnet will have all the IP addresses starting at 0.0.3x. Okay. And let's see. Now we're going to choose create subnet. Awesome. I want to take a screenshot right here. So the second private subnet was created. You will now configure this new private subnet to route internet bound traffic to the NAT gateway so that the resources in the second private subnet are able to connect to the internet while still keeping the resources private. This is done by configuring a route table. A route table contains a set of rules called routes that are used to determine where network traffic is directed. Each subnet in a VPC must be associated with a route table. The route table controls routing for the subnet. So on the left navigation pane, we're going to choose route table. Select a lab RTP private 1 US East 1 route table. Let's see which one is it. So on the route table, we need to choose this one right here. I don't see which one that is. So in the route table, we'll select the lab RTB private 1 US is 1 route table. Which one is that one? Is it this one? US is 1 route table. This is public route table. I don't see any like call lab TBR private is 1A route table. Was anyone named that? Lab RTB? Nope, I don't see any. What is this one? How do I know it is this one? Let me click into it. Was this private or private 1? So not this one. Private 1. Is this private TBR? No. Interesting. Let me go back. Did I miss anything? Which one is it? I don't see. I don't see where it say lab RTB private. It's 1. Is there any other one beside that? Interesting. Oh, is this one? No, this is your VPC. Where does it say? So let me choose lab VPC, right? And inside we'll choose route table. Still doesn't have that. It's ask us to Where is it? We'll choose route tables. That's what they ask. Right, subnets association. Look like they doesn't have anything here. What about this one? Subnet association. What about route table? Oh, okay. So it's probably just was creating. Now we have this lab RTB private one US one right here selected. Okay, select this lab RTB private one US one is one US one A1 1A. So it was probably was pending or creating. Now it is finished, so we have this option to select the lab RTB private one US East 1A. So now what we're going to do is we're going to go in the lower pane and choose route tab. Okay. Note that the destination is 0.0.0/0 is set to the target not XXX right here. This means that the traffic destined for the internet 0.0.0.0/0 will be sent to the NAT gateway. The NAT gateway will then forward the traffic to the internet. This route table is therefore being used to route the traffic from the private subnet. So we're going to choose the subnet association tab right here. You create this route table in task 1 when you choose to create a VPC and multiple resources in the VPC. That also create the lab subnet private one and associated subnet with this tables. Now that you have created another private subnet, lab subnet private 2, you will associate this route table with the subnet as well. Okay. So next, what we're going to do is in the explicit subnet association panels, we're going to choose edit subnet association. And then we're going to leave the lab subnet private one US is one selected. But also select lab subnet private 2. Lab subnet private 2. Okay. Now we're going to choose save association. You will now configure the route table that is used by the public subnets. So select the lab RTB public route table and select any other and deselect any other subnet. Lab RTB public. Lab RTB public and deselect everything else. Lab RTB. In the lower pane, we're going to choose route tab right here. Note that destination 0.0.0.0/0 is to target IGW, which is an internet gateway. This means that the internet bound traffic will be sent straight to the internet via this internet gateway. You will now associate this route table to the second public subnet you created. So we're going to choose the subnet association tab. And in the explicit subnet association area, choose edit subnet association. Edit subnet association. Leave the lab subnet public one US East 1A selected, but also select lab subnet public 2. Lab subnet public 2, and then we're going to save the association. Okay. Your VPC now has a public and a private subnet configured into AZs. The route tables you created in task 1 also have been updated to route network traffic for the two new subnets. So next, we're going to create a VPC security group. In this task, you will create a VPC security group which act as a virtual firewall. When you launch an instance, you associate one or more security groups with the instance. You can add rules to each security group that allow traffic to or from its associated instance. So from the navigation pane, we're going to choose security group. And then we're going to configure it. The security group name is going to be web security group. And the description is enable HTTP access. The VPC, we're going to choose X to remove the current selected VPC. Then from the drop down list, we're going to choose lab VPC. Okay. In the inbound rules pane, choose add rule. Inbound. The following setting type is HTTP. Source is anywhere IPv4. Description is permit web request. Now we're going to scroll to the bottom of the page and choose create security group. You will use this security group in the next task when launching an Amazon EC2 instance. Okay. So task 4 is launch a web server instance. So in this task, you will launch an Amazon EC2 instance into the new VPC. You will configure the instance to act as a web server. So in the search box to the right of service, we're going to search for choose EC2 instance. So let me go to the new window, choose EC2, and then from there choose launch instance from the menu to choose the launch instance, and then name the instance going to be web server 1. So when you name your instance, AWS creates a tag and associate with the instance. A tag is a key value pair. The key for the pair is name and the value is the name you enter for the EC2 instance. Choose an IAM from which to create the instance. In the list of available quick start AMI, keep the default Amazon Linux selected. Okay. Also keep the default Amazon Linux 2023 AMI selected. Okay. The type of Amazon machine image AMI you choose determine the operating system that will run on the EC2 instance that you launch. So choose an instance type. In the instance type panel, we're going to keep the default T2.micro selected. Okay. The instance type defines the hardware resources assigned to the instance. Now select the key pair to associate with the instance. So from key pair name menu, select a Vaki. Okay. The Vaki key pair you selected will allow you to connect to this instance via SSH after it has launched. Although you will not need to do that in this lab, it is still required to identify an existing key pair or create a new one when you launch an instance. So configure the network setting. Next to the network setting, we're going to choose edit and then the following. For network, it's going to be lab VPC. For the subnet, it's going to be lab subnet public 2. Auto assign public IP enable. Next, you will configure the instance to use the web security group that you created earlier. So under firewall security group, choose select existing security group. And then for common security group, select web security group. This security group will permit HTTP access to the instance. So in the configure storage section, keep the default setting. Note that the default settings specify that the root volume of the instance, which will host the Amazon Linux guest operating system that you specified earlier, will run on a general purpose SSD GP3 hard drive that is 8 GB in size. You could alternatively add more storage volumes, however, that is not needed in this lab. So configure a script to run on the instance when it's launched. Expand the advanced details panel. Okay. Scroll to the bottom of the page, then copy and paste the code shown below into the user data box. Okay. This script will run with root user permissions on the guest OS of the instance. It will run automatically when the instance launches for the first time. The script installs a web server, a database, a PHP libraries, and then downloads and installs a PHP web application on the server. So at the bottom of the summary panel on the right side of the screen, choose Launch Instance. You will see a success message. So wait until web server 1 to check pass in the status column. This may take a few minutes to refresh icon at the top of the page every 30 seconds. Also to more quickly become aware of the latest status of the instance. You will now connect it to the web server running on the EC2 instance. Let's see. Let's view our instance. It's all running. Status right here is initializing right here on the web server 1. But after it's finished, we're going to want to select the web server 1. Okay. We're going to keep refreshing every 30 seconds also. Let's see. Okay, let's see what's the next one. What we need to do is just wait until it's the check already passed, and then select web server 1. Then we're going to copy the IP, the public IPv4 DNS value, so in the details tab at the bottom of the page, and then open a new web browser tab, paste the public DNS value and press enter. You should see a web page displaying an AWS logo and instance meta data values. The complete architecture you deploy should be looking like this. They have the AWS cloud regions, AZA and AZB, and we have this lab VPC in here, and yeah, there is a lab subnet public one, lab subnet private one. There is NAT gateway. There's an internet gateway. In AZB, we have a lab subnet public 2. Also inside there is a security group web server 1, and we have the lab subnet private 2 as well. Let's refresh this. So it's still running, so we need to be patient and waiting for it, and yeah, just wait. So we're just going to wait for it. Okay, so I guess okay, so that's why it's work. So the web server 1 subnet instance is working. So we copy the public IPv4 DNS and paste it in here. So all this metadata value in here, and so everything's work. So thank you so much for watching. I hope you have a great day. Thank you and bye bye.